and make sure your interests are being covered. So in particular, why am I here today? I'm here to talk about class-based views. In particular, the reason I'm here talking about this is that they were introduced in Django 1.3 as a wonderful new feature, but they have not been, shall we say, greeted with universal enthusiasm. So let's clear up the mess. What are class-based views? Why do they exist? And why should anyone care? Now, I'd like to emphasize this isn't a tutorial. It's an attempt to set the big picture straight in the hope that by getting the big picture straight, some of the broader discussions about class-based views that I keep seeing on mailing lists or topics that keep coming up on Twitter will have a slightly better direction, or at least stop being so badly wrong. So, okay, we're talking about big picture pictures here. Okay, so if we're talking about big picture, we've got to explain why we've got what we've got, so it helps to know where we've come from. In the beginning, it was 2005. Django is there to build websites. We got the wonderful introduction this morning from Simon Willison about what happened in those early years. It's open sourced in July of 2005. It's there to help you build websites. Views exist. Views are the way that you display content. There are lots of common patterns in views. We all like being dry. The generic views weren't there in the first public code release in 2005. They were added on July 25th in revision 304, so the 304th commit in our public repository after we went open source. Why were they added? Well, because there are common patterns. There are things that you end up doing all the time when you're building generic views. So, refactor all the things. There are common stuff that you do. You need to be able to display a template. You need to be able to display a single object. You need to be able to display a list of objects. You want to be able to create a display and create a form and then perform create, update, delete type operations upon it. And again, because this is Django comes from a journalism background, displaying date archives. Show me all the articles that were written in 2005, in August, etc., etc. The things that are common here, though, is that every view is a function. And in the generic view context, those views can then be configured using arguments. So let's take a common example. Here is a generic view being done, written longhand in Django. So we've got an edit book. We want to edit some record about a book. We get a book ID as part of our view's arguments. We're going to edit a book with ID, book ID. First off, we've got to get that book. We do a try-catch to say, okay, go to the database, get the content of that book, and if it doesn't exist, raise a 404. Okay, then we go and do a bit of form management here. If the request is a post, then we need to construct a form, populate that form with data that's come from the post and with the fact that it's from this particular book instance. If the form turns out to be valid, then we save the form, which saves the object, updates the object, and we redirect to wherever the home of that book object comes from. If it's not a post, if it's a GET request, then we just need to instantiate the form. We don't have to do anything with post data. And at the end of the day, what we need to do is then render, using some particular template, some context that has the object we're rendering and the form we're rendering, render that back to the user. Okay, nothing surprising there if you've used Django. That's completely it would have written that code many, many times before. You then get that view and you attach it to your URL pattern. So you have a URL pattern that says, when I ask for book number 3, the regular expression will match there, call it book ID, pass that into book view as the function, and for convenience sake, we're going to call that URL edit book. The idea behind generic views is to say the view we wrote is exactly the same for every object we're likely to want to do that with, except for the word book. So let's find a way of abstracting that out. And what you end up with is the after. You replace your custom handwritten view with boilerplate code with generic.updateObject. You pass in the model you want to deal with, book, and you use all the internal magic that Django has in terms of knowing what a book is to automatically generate the form and then work through the logic for the rest of that edit view method. Now, important to point out, this code doesn't actually work anymore because of class-based views. The original generic methods have been deprecated. But this was, as of Django 1.0, the way you did it. There was a bunch of functions in the library for doing generic views. And so, okay, this has been done with book. If we want to switch it over and instead of editing books, we want to edit authors, you do exactly the same thing. You replace the references to book with the references to author, update the URL pattern to say where we're mounting it, you update the name of the URL, and that's all the code you need to write. You don't need to write the boilerplate of this is how a form works ever again. Fantastic. So why is there a problem here? Okay, well, the configuration of that view is entirely constrained by what you can pass in as an argument. There's no control over the flow of logic inside that view. And there's no reuse between views if there is logic that needs to be, that is consistent between views. So for example, if you want to instantiate a different form based upon some property of the object that's been requested, you know, if it's a library book, you want this form. If it's a personal collection book, you want to render that form. You can't really do that using function-based generic views. Let's say you want to perform logic after form validation, but before the form is saved. Well, unless you can put that logic in the form's save method, generic function-based views don't give you a mechanism for doing that. What if you want to pass in extra arguments to the form instantiation, like, say, for example, the request, because that's kind of going to have some useful information in there, like the user who is currently logged in? Well, you can't do that either. What if you've got something like common permission logic that you want to run? Well, unless you can put that in a decorator around the entire view, you can't do that either. Okay, so how do we address these problems? Well, you can keep adding new functional entry points. You can keep making the prototype of the generic functional view more and more complicated, which is one thing we did for a very long time. Version 1.1, 1.2 added a bunch of new arguments to provide new configuration points and provide new configuration arguments. But eventually, you kind of just end up poorly implementing half of the features of class inheritance. So here's an example of this in practice. Let's say you go back to our edit book example view. If we've written this code manually, it's easy to say, well, if the form is valid, before saving, do something. You just drop in book.prepare or whatever other functional logic that you want, and you do it. But if you've got this as a generic functional-based view, that entry point doesn't exist. So what do we need to do? If we were clever, we might be able to sneak that save method into the form's logic, but that won't necessarily be the right place. Say something like popping up a flash notification, a message you want the user to see the next time they view the page. That's not really a form action. That's kind of something that's about behaviour of your way your system to work. And sticking that logic in your form, because that's the only place you can put it, is the wrong way to look at architecting a system. Another example is something like permission checks on individual objects. This is something that needs to be done on every view that looks at a single object. You can't really put that in a decorator around the outside of the view. You need to be deep in the weeds in the logic of your generic view. So that's kind of hard to do. So we need to refactor all the things, clearly. Let's go class-based. If all we're going to be doing is badly re-implementing all the features of class inheritance, then, OK, let's just use class inheritance. Subclassing gives you the ability to say, here is a piece of logic. I'm going to subclass to change this and override that specific piece of logic. That's exactly what classes are supposed to do. And you can use mixins to then compose behavior out of different areas. Fantastic. It's not quite that simple, though. There are lots of details that need to be sorted out. The discussion around class-based views went on for many, many years. There were a number of draft attempts at this. Jacob Kaplan-Moss, Joseph Cochran's, Ben Furshman all had attempts at doing a class-based view framework, which got to various levels of completion. Ben Furshman's is probably the most complete before I got involved. And they'd all evolved on each other, sort of building on the work of the previous one. I'm here because I'm responsible for the final push. I took the work that Ben and Joseph and Jacob had been working on and turned it into the final patch that we all know as what we now have as Django's generic class-based views. And that landed in Django 1.3. And that's where the wheels fell off. Why? Well, there's a couple of reasons. Firstly, there was lots of confusion over what class-based views are and what they can be used for. There's two very distinct purposes, two very distinct use cases here in class-based views, and they were wrapped up in a single commit. Second, the implementation of class-based views isn't immediately obvious. It does a couple of slightly odd things, which if you're coming at this for the first time and thinking, well, I'm going to build my own class-based view, the way Django has done it is probably not the way that you would do it as a first pass. The reason we do it differently is that we did the first pass, and then we realized the problems with it. The third criticism is what's referred to as ravioli code. I'll come back to this. Ravioli code is a term that was actually coined by one of the Django core team, Luke Plant. And it's an architectural concern. It's a legitimate criticism. What does it mean? I'll come back to that in a second. And probably the last one of all, particularly given our keynote speaker this morning, the worst part was the bad documentation. I take full and complete responsibility for the appalling state of the documentation when it landed in 1.3. Since that time, Mark Tamlin and Danny Greenfeld and a number of others have done a great job at improving the mess that I'd left. If nothing else, it serves as a wonderful example of why the person who built it shouldn't write the docs, because I was just too far deep in the weeds to come up with a good set of documentation. So, mea culpa. I will do better next time. Okay, so let's go over those 4 problems in depth. The first one is purpose. When people talk about class-based views, there's confusion over exactly what they're talking about. They could actually mean one of 2 different things. Are they talking about class-based views, or are they talking about class-based generic views? There was one commit, but 2 very distinct features in that commit. A class-based view is just the class-based analog of a view function. Django says that the prototype, or the operating definition of what you can execute is a view. A view is just a callable that takes a request and returns a response. Due to the wonders that is Python, that means it can be a class as well. And so a class-based view is just how do you write a class that can be used as a view. It doesn't have any of the extra stuff about creates and updates and all the rest of it. It is purely method-based HTTP verb dispatch, by which I mean HTTP verbs are the gets, the posts, the puts, the deletes, the protocol level definitions of what HTTP does. Class-based views just provide a wrapped implementation of getting access to that. Okay, so what do I mean? Once upon a time, you would write a function that is that you deploy into your URL patterns. As of Django 1.3, you can write a class-based view. You have a class called myView. It extends view. It implements a method called get. It implements a method called post, and they are used to handle, surprise, surprise, gets and posts. Along the way, because it is class-based, because you are inheriting functionality from somewhere else, you get automatic options handling. So HTTP has this verb called options, where you can say, what can I do to this? Can I do a get? Can I do a post? We know which methods you've defined, so we can answer that question for you automatically. We do automatic naive header handling. Again, head is a type of request you can issue to a HTTP server, and it says, essentially, give me back the headers, but not the body of this request, of the request for this resource. We can do that by just doing a get and not giving you the body. Now, okay, that's obviously not the most efficient way of doing it, because you are still computing the body, you're just not returning it. But as a first pass, it's a reasonable approximation, and it will enable you to support head requests. It also gives you an automatic HTTP 405 for unknown verbs. So if you have written a server, and you say, well, okay, I don't want to handle puts. You don't provide a put method, it won't handle a put. And it will return HTTP 405, I only accept head, options, get, and post, or whatever subset you've actually defined. Interestingly, if you do that on a function-based Django view, and you pass in put, it will just return it as a get, which might be right, but probably isn't. So effectively, what we've done here is provide a framework to let you actually give you better HTTP protocol support. Okay, so that's class-based views. Class-based generic views take that class-based view base and then creates analogs of the existing generic views that were in Django's core. So the create, update, list, archive, data archive type functionality. Addressing all the limitations of the functional approach, in that we need to be able to create a different form or control the process by which forms are instantiated or put logic into a different place in the validation chain. But it was the mandate for what was committed is replace exactly what is there, not try and come up with a whole bunch of new functionality. It's replace what was there with something a little bit better. The catch is that by addressing all of those limitations, there's a whole new body of knowledge that you need to acquire, and this is where the documentation fell down. How and where you extend those classes becomes the knowledge you have to have. It's also the basis of the Ravioli criticism, again, which I'll come to in just a moment. The second criticism that gets leveled against class-based views is the implementation choice. The approach we took, and we ultimately get, isn't the obvious one. Okay? When you deploy a class-based view, you have to have this as view call. And most people sort of say, well, why don't you just use call? There is a reason for that. That in itself is an entire talk as to why we went down this path. The good news is the decision process is documented. If you go to Django's wiki, we actually have the design decisions fully documented for what we looked at, what we considered, and why we rejected the things we rejected. It's worth reading just to sort of see how we got where we are. And we're trying to do this more and more with new features, as they get added to Django. The dep process that Adrian sort of informally announced, and then we haven't really done great work with, it kind of is an advanced version of this, what we've currently got on the wiki. So yeah, if you want to know why we've got what we've got, there's a very good reason why, and it's to protect essentially developers from making mistakes that are potentially very, very dangerous. Okay, so ravioli. The ravioli criticism comes about because there's a very steep learning curve. Our goal was to replace function-based generic views with class-based generic views that were exactly the same, and to show what the class-based approach could allow you to then do. Our endpoint views that are used by people at the end of the day are constructed out of a series of much smaller mix-ins, each of which implements a small part of that larger functionality. Ravioli code is a term that was raised by Luke Plant, and effectively what it's describing is the fact that whilst the end package is delicious and attractive, you don't want to ask too many questions about the internals. They're minced and they're unclear and very, very hard to pick apart. And if you're an expert, you can make great ravioli. But if you're a newcomer coming at a piece of ravioli, you can't work out the recipe without going and doing your 3-year cooking course. Now, this is an entirely legitimate criticism. The generics, the class hierarchy that exists in class-based views is very complex. And in order to use them at all, you kind of need to wrap your headspace around the whole thing. And that's hard because there's a lot of stuff there. The minimum quantum that you need to understand in order to use any of it is all of it, effectively. And that's not good. It's very hard to document, I know, because I failed. The documentation is now much better in that regard. But that's the problem we've got. There is this learning curve. And when we've got a framework that's designed to be accessible and friendly to newcomers, having a steep learning curve is a bad thing. So, here's my ravioli cooking course. Let's take that original view that we started with and break it down. Taking even more pseudocodey kind of versions of that view. Edit view is essentially get an object. If it's a post, get the form. If it's valid, handle the form and redirect. If it's not valid, handle the failure in some way. Otherwise, get the form without any post data interaction and return a response. The way that Django's class-based generic view framework looks at this is this. So, we start with a single object mix-in. We have an object, we're dealing with viewing a single object. The behavior to get a single object is consistent regardless of whether you're creating it, updating it, and all the rest. You just need to be able to do a get. So we've got a single object mix-in. We also have a descendant of single object mix-in, which is a context mix-in, which says, how do I get that information and stick it into a context I'm going to use at the end of the day? We need to be able to say, okay, this is a view that's going to deal with gets, posts, and puts. So we have a process form view that knows how to do the basic logic around if I'm a post, otherwise do this other thing. We have a single object template response mix-in. Oh, sorry, we have a form mix-in that says, okay, well, if I'm dealing with a form, in particular, if I'm dealing with a model form, because there's a model form mix in there as well, the model form says, well, this is particularly how you instantiate a form when it is a model form. But some of the base behavior about how you deal with forms, you need to know if the form is valid, if the form is not valid, handle the form if it's successful, handle the form if it's not successful. All of those functionality is just part of the basic form mix-in, which is then extended further up into a model form mix-in, because if you know you're dealing with a model form, there's a few specific things that you can specialize even more. Then we have a single object template response mix-in, which says, okay, I am rendering a template, and the template is showing you the result of dealing with a single object. It takes the result of the single object's context and puts it into a template that is being rendered. And it is a template response mix-in that takes it and turns it into rendered content via a template. And then at the whole top of it, so at the whole top of it is the update view and base update view, which kind of wraps around the logic to say, okay, well, this is how we pull all of those pieces together into a view we can actually do something with. We end up with 9 classes to do the simple task that previously used to be one function. This is the ravioli, because you kind of need to know all of those in order to be able to extend it. The upside is once you do, changes become relatively simple. So, for example, we want to say create instead of update an object. Well, all you need to do is change the bit at the top. The way you're instantiating the object is slightly different. Okay, so instead of getting an object based upon an ID, we are creating a new object from scratch. The only bit you really need to change is the instantiate object, which is the bit that's handled by base create view, previously base update view. Okay, so what about if we don't want to change whether it's a create to an update? What we want to do is, instead of returning a template, what we want to return is a JSON response. Well, okay, again, all you've got to do is change the bit down the bottom. The way you're dealing with a single object, the way you're rendering a context, none of that has changed. All that's changing is the object you've got needs to be pushed to JSON instead of being pushed through a template. So you change the one thing at the bottom, the single object JSON response mix-in, and it stops using template language and it starts using JSON instead. And there's a whole bunch, obviously this is, every one of those classes has 2 or 3 extension points you can get into to control the workflow around what's on the left-hand side, the basic workflow of dealing with a create or update type view. It also means we've got reusable logic. So if you want to write your own custom view that is doing something particularly fancy, but it's doing it to a single object, you can pull in the single object mix-in and just exploit the logic that is there. So what does that look like in deployment? Well, okay, once upon a time we had our generic.update object, and that was a function. And the function, we pass in an argument that says the model we want to deal with, it's a book, and it gets called and invoked, and it just gets handled as a view. It behaves like a view. After class-based generic views, what do? Almost exactly the same thing. It's changed from lowercase to uppercase because we're dealing with PEP8 and classes have uppercase names. We have a little bit of extra, the as-view bit, and we're passing in the model we want to work with as an argument. Okay. The catch here, and the bit that most people get stuck on when they say, hang on, why are you doing this? This seems weird. Couldn't class-based views be a whole lot easier if we didn't have that, is why is add view required? Essentially, it's required to make sure that the state of a view is unique between requests. The simple approach, just make the class callable, means that if you've got 2 users using that same class instance at the same time, one person can potentially see what's going on the other object, which means all of a sudden you've got state leakage between 2 different users. Okay? So that means you've got potentially a whole bunch of security problems, and the only real defense you've got against it is to say, don't store anything on the class. Instance variables of the class will cause security problems, which, okay, sure, we could do that, but that's kind of like saying, here's an elephant gun, new user, please don't point it at anyone. It's asking for trouble, and so we avoided asking for trouble by getting the trouble out of the way altogether. The thing that's interesting is that Django's own source code actually makes that exact mistake. If you look at Django's admin is a class-based view that is behaving as a callable. So if you ever store anything stateful on your model admin, it potentially will leak between uses or leak between different requests. Now, the good news is that all of the documented ways that you use Django's admin don't tell you to do that, and there are patterns. The patterns that are out there for using Django's admin walk you away from doing the bad thing. But it's worth knowing it's there because, hey, we made the same mistake. Okay, so we can clarify. I've got here is we're instantiating update view using as view right in the URL pattern, but we can actually also do that. That syntax is essentially just a syntactic sugar around defining a subclass that has an argument or that has a class-based attribute, model equals book. Or you can subclass it and do a whole bunch of other interesting things like overriding individual methods. If you do that, then instead of having the passing in arguments to as view, you just instantiate the class that has the arguments you want as view. But other than using up 3 more lines of code, why would you actually want to do this? Well, it's because you can do a lot more to update view. You can do things like add form valid as a class method, or sorry, as a method on the class. What does that do? Well, okay, it means when it gets to the point where you're dealing with the update and it says, okay, establish that this form is valid. If it's valid, call form valid. By default, on a model, on a class-based, an update view that's dealing with a model view, it will call form.save, and that's essentially all it does. But if you want to get in there and do something else, like say our object.process, the model.process we had before, you can do that. You just got to inject yourself into the workflow. And if you want to do something after, well, then you just got to, the super call, you put something after the super and you return the value that you need. What about things like permissions mixins? Okay, well, you've got. You can have a get object is kind of the mechanism by which a single object mixin does its thing. It's just get object. So if you can override the way that get object works, you can inject permission logic. So any attempt by the database or any attempt by the view to get an object will go through your permissions hierarchy as well and return a 404 or whatever response that you want to have that comes out of that. Okay, now, as a side note, the form valid override in the previous slide could also have been done as a mix-in. It's just a question of how reusable that logic would have been in practice. A specific post-save behavior probably doesn't have a whole lot of widespread reuse potential, so an override in a subclass makes sense. Permission checking is something that's more likely to be widespread behavior, so a mix-in is probably warranted on that basis. Okay, so like I said, the price you pay for all that tasty ravioli is a learning curve. How do you know that getObject is the method you need to override? How do you know that formValid is the right entry point for that logic? The only fix for that is documentation. And like I said, the technical term for the state of Django's documentation for generic class-based views when they landed, the technical term was that they were bad. It got all the details 100% correct, but completely missed the big picture. It's like the analogy about the person floating by on a hot air balloon past a tall building, yells out of the hot air balloon, "Hey mate, can you tell me where I am?" And the guy in the building says, "Yeah, you're in a hot air balloon." Completely correct, but utterly useless as information. So the big picture is right. But the details are correct, but the big picture is completely missing. The documentation is now much better in that regard, and there are projects out there like Mark Tamlin's CBGV.co.uk, which is essentially an interactive exploration of the methods in class-based views to try and work out maybe where you should be injecting logic in. There's also a couple of framework-level decisions that the core team, or more broadly the Django community, kind of needs to make. For example, take something like a login required functionality. I want to be able to control who can see this view. They need to be logged in order to see this view. Do you do this as a decorator? Do you do this as a mix-in? Do you do it as a class decorator? There are multiple ways to do it, depending upon exactly where you want to inject that logic. We kind of, as a community, or particularly as a core team, but also broadly as a community, need to bite the bullet and just kind of pick one. Document it, and then ship a login required mix-in, decorator, whatever, as part of that. Okay, so where do we go from here? Well, documentation can always improve. Like I said, it's a lot better than it used to be, but that's not to say it couldn't get a lot better still. There are probably some high-level decisions that need to be documented, and that's kind of hinging on actually having the decision being made in the first place. We can extend what is already there. Like I said, the original, as a scope constraint exercise, the original project basically said, we are replacing the old generic views, and that's it. We could have kept going, because there are things that the original generic class-based views don't do. Obvious one, there's no handling for form sets in the original generic views, so Django's class-based generic views don't handle form sets. There's also the inline plus form set, or form plus inline. So the classic model that the admin has of here's the details for one object and all of the objects that are related to that object as tabular inlines underneath. We don't have a generic-based way of looking at that sort of structure, even though admin does it. So why haven't we added those in the intervening years? It's been, 3-4 years since 1.3 landed. So it's been a while. Why hasn't this sort of stuff happened? Well, okay, two reasons. The first is a lack of enthusiasm. At the risk of sounding all woe is me, this can operate as an active lesson to everyone as to how words that are spoken online have consequences. I spent a lot of time working on class-based generic views. I did that on the back of 3 or 4 other people who have spent a lot of time working on class-based generic views. We asked for feedback, we got feedback, we integrated that feedback, and the design evolved over many, many years. And even today, years after the class-based views discussions have been committed and it's all there, I keep running into these discussions where I'm having to defend decisions that I have defended many times in the past, and I can point them and say, the decision was made over here, and there's a reason we made it. And eventually, just the enthusiasm for running into a lion's den and having to defend this stuff one more time, it becomes so exhausting is that it's easier to go find another problem to solve. Others who might have volunteered then also get scared off by this environment. So the next time you jump on Twitter and vent your spleen about something, and you aren't planning to follow that tweet with, and here's a patch to make it better, please consider the consequences of your words, because just getting out there and venting about how this sucks and it will never improve and how could the guys have been so dumb for doing it this way really does suck the oxygen out of the room for getting anything done with volunteers. Okay, but enthusiasm is one reason, and okay, I don't want to end this on a bad note. There is another reason. Before we start charging into new features, I'd like to ask the community more broadly a question. Have we solved the wrong problem? If we go back to 30-odd slides ago, I put this up as a list of features that generic views had to solve. You have to be able to display a template. You have to be able to display a single object. You have to be able to display a list of objects. You have to be able to display a form, create, update, and delete that form. You have to be able to display a date archive. In 2005, that was a common list. That was what websites did, and it was revolutionary to be able to do that in one line. Modern websites have different problems, or at least much more involved variants of the same problems. You look at a modern website, something that's going to hold its own in sort of the field of apps that are being developed right now, you don't just have an object per page. You've got multiple forms, multiple form sets per page, and you may only be submitting some of them because you've got a complex user interface and only some of that information is being committed. It's not just a list. It's a continuous scrolling list rather than a paginating list, or it's a dynamically updating list based upon data that's coming in live off the wire. You don't go to a form, edit a form, and hit submit. You may well have to have AJAX support, in-place editing for a view of something that's currently in the database, or on-screen validation for a form that's currently there. We've got things like PJAX, GitHub's user interface, where it doesn't look like the page is actually reloading. You've kind of got this banner that's always there, and there's content that moves underneath it. The URL changes, but the content is always there, or the header is always there. So it looks like it's a persistent application. There are clever ways of doing it. It's called PJAX. You've got, you might want to do multiple actions per page. It's not just, here's a form, hit submit. It's, well, here's the edit, and here's the delete, and here's this other thing. And you want all of those buttons to be on one page. You've also got rich JavaScript-driven user interfaces. The emergence of frameworks like React and Angular and Ember. These are all part of building very rich client-side experiences. Django has historically, as a result of where it's come from, stood there and said, okay, we're a server-side framework. This isn't our problem to solve. It's up to you to build the client, and we'll build the server and give you tools. But these days, the two need to interact really closely. And this is why things like Node.js get really good traction, because you just build the one language on both ends. For the love of God, I'd like to not have to build JavaScript for a living, particularly not on the server. So is that our only option? Surely there must be a better way here. If we can get better integration between a client-side framework and Django, then I think we should be pursuing that. In particular, the concept of API-driven user interfaces. If you're trying to build a product, really what you're doing is you've got a user interface. A user interface is just a way to let Meet push buttons on a website, so that then other people who aren't Meet can build computers that will talk to your website. If Meet can push a button, why shouldn't a computer be able to push that button as well? And if we start thinking about your user interface as an API that has a skin that a human can use, then you start thinking about your projects in a completely different way. So, a modern website is just an API with a user interface. A user interface is a way to get Meet to invoke that API and a way to visualize the results of that API in a way that Meet can understand it. Now, I hope that the value of APIs, broadly, is something that we kind of just take for granted as engineers who have been doing this. But if we rethink the way that we're building applications and treat APIs as documented version, first-class citizens, and sort of, they are the prime reason for how we build this stuff, then that enables others to remix and reuse that data. It enables other people to build alternate user interfaces to your data. and there isn't any, I can't think of any reason why an appropriately authenticated automated process shouldn't be able to do everything that an appropriately authenticated human can do. If we treat APIs as first-class citizens, then all this sort of stuff happens for free, and you don't have to worry about this god-awful interface that the Transport Department has left you with for working out where the buses are going to come on time. You can build a better one because you've got access to the data. Now, API-driven server-side interactions are really easy in Django. The API part is easy to solve. We've got the Django REST framework, we've got TastyPy, we've got others that are in the community, but we still need to have that view side of things. We need to be able to represent the ideas of navigation and composition. And in order to be able to do that, we need to have a strong base framework. My argument is that class-based views potentially provide that framework. Notice I'm saying class-based views here, not class-based generic views. I think generic views are solving the wrong problem. They're trying to solve the 2005 problem. We need a new set of class-based views that look at this problem slightly differently, that look at the problems we have on websites today. How do we build that? How do we build that to interact with an API? Now, how can I say with confidence that class-based views provide that framework? Well, because it's already basically being done. It's called django.contrib.admin. Django's admin is, at its core, a class-based view. It's not using Django's class-based view framework, but it uses something that's sufficiently close as to be, to be able to say the analogy holds. It's implemented using a single call method, which, again, like I said before, has this security problem. But we could avoid that by migrating Django's admin to our own call-based framework and eating our own dog food. It doesn't have HTTP verb support, which Django's class-based view framework does. And it suffers from state problems. The good news is that all that stuff probably doesn't matter. It's relatively easy to adapt around those problems and get Django's, and we could migrate Django's admin to our own class-based view framework. But I'm also not necessarily saying that Django's admin is where we should be starting, or at least Django's admin as it currently stands is where we should be starting. What I'm kind of talking about here is that admin as an idea is a website that has all these problems. There is an API that's there. We need to be able to manipulate objects at a raw level. We need to be able to put a pretty user interface on top of that API that lets you see a list of all the available objects and an object and all of its related objects, and make it easy to be able to say, well, here's these 4 bits of core functionality that I want to be able to interact with this list or interact with this object. It's also something that is a very, very big blue sky project. I have ideas. I certainly don't have all the answers. It's a blue sky project, but it's one that I am interested in. And as an interesting side effect, it also doesn't need to be part of Django's core. Django's admin is distributed as part of core, but that's really a conceit of packaging. It's born because of the fact that in 2005, pip install Django didn't exist. You had easy install, and easy install, depending upon where the moon was, wouldn't necessarily bring in all of its dependencies. That problem's been fixed. We know how to do that now. So we can have a package that is completely external to core that plays around this space and builds a much richer API-driven, introspective, class-based admin that is the kind of framework we can work forward. And Django, this new imagination of admin is really just one manifestation of the broader set of API-driven user interfaces that have pieces of functionality on a page. In a sense, admin is really just an introspective application of the API for building this type of website that we could have. So this is essentially a call to action here. In discussion, when you're talking about class-based views, please be clear about whether you're talking about class-based views or class-based generic views. I will wear a lot of the faults with class-based generic views. A lot of it is documentation related. That's not to say they couldn't be improved. Docs can always be improved. There are patches that are sitting there in Django's ticket tree, like 18.8.30, which is extensions to Django's existing class-based views to make a whole bunch of other things more possible. If you're interested in making what is there better, there are ways you can contribute in a practical way. But more broadly, I'd like to encourage people to think about the bigger problem here. Django's long-term future depends upon us being able to compete with the Meteors and the Nodes of the world who are going out there saying, look at this wonderful demo. In 2005, building a blog in 10 minutes was a huge accomplishment. Now, you're going out and competing with Meteor, who are building real-time chat servers in 5 minutes. We don't have a good answer for that, and we should. Because if we're going to be a long-term project, we need to see where the way that the wind is blowing and be able to adapt to it. And Django's admin, for me at least, is a very useful case study of a complex piece of functionality that is directly applicable to this problem. So with that, open the floor for questions.